binomial theorem. So a binomial is a polynomial with two terms. So for example, x plus y. Okay, in principle, we can raise this binomial to any power and find the expanded version of it. So we can have x plus y to the power 0, x plus y to the power 1, x plus y to the power 2, 3, etc. But finding the expanded version of any higher powers would be very tedious. Hence, we use the binomial theorem to allow us to expand any expression of the form x plus y to the power n. Now, in the past, I've asked you to work out these things, and it's generally caused quite a lot of angst and issues. And so I've actually done it for you. How did I get 1 if I raised something to the power 0? Lovely. Anything to the power 0 is 1. X plus y to the power 1 would obviously just be x plus y. X plus y squared. How could we find x plus y squared? Foil. So we'd write our two brackets and we would expand it. Okay? Using whichever method that you get. Once you simplify it, you'd end up with this. X plus y cubed. I just want to make sure that you would be comfortable finding x plus y cubed if you should have to.
I wouldn't be either.
Okay, so I'm going to help you out with x plus y cubed. So x plus y cubed obviously means this. So if you have 3 brackets, you need to focus on 2 of them to start with. Doesn't matter which 2. I'll focus on these 2. And I'm going to use FOIL to expand those. So we would have x squared plus xy plus xy plus y squared. This middle term obviously simplifies to be 2xy. So from the expansion of those 2 brackets, we've now got an expression with 3 terms, x squared plus 2xy plus y squared. If we're now to multiply by our 3rd bracket, we would multiply each of these terms, the x plus y, the 2x and the y squared, by each of these terms. So we would have, it doesn't matter which way you would do it, I'm going to focus on my x to start with, so I'm going to multiply all of these 3 by x. So I have x cubed plus 2x squared y plus xy squared. Now I'm going to multiply them all by the y. So I've got plus x squared y plus 2xy squared plus y cubed. And then obviously I would simplify like terms, or join like terms. So I've got 2xy squared here, and then x squared y here, which gives me my 3x squared y here. Sorry, I should have started with this one. So my x cubed is here. My 3x squared y we've talked about. I've then got xy squared and 2xy squared, which gives me this one, and my y cubed. Okay. Okay, so these ones, the top 4, you would be expected to be able to do yourself on the non-calculator paper. It may come up, but it also may be useful or helpful for you to remember these ones, especially this one and this one, to be honest, because they do come up quite a lot. So to remember what x plus y squared would give you is perhaps quite a good idea. If we were to expand any further, this is what you would end up with. Okay. Now I want you to take a few minutes and just have a look at this pattern. So obviously we can see we'll x plus y to the 0 to 1, 2, 3, 4, 5 and 6. So I want you to consider, how do you think we can describe x plus y to the power n? So we want to try and relate everything to either the x or the y or to the power n. So think about the number of terms, look at the powers of x, what happens to them. Look at the powers of y, what happens to them. Look at the coefficients of each term. Do they follow any kind of pattern? Okay, so we're going to give you a few minutes to have a think about that. All right, so we need to perhaps make sure we all know what the word coefficient means. What does coefficient mean?
The number in front of x.
Number in front. Yeah, it just means number in front. It could be in front of anything. Okay, so the number in front of, let's just say the variable. So, but let's start up here at number of terms. So how many terms are there in relation to either x, y, or n? Did we look at that?
So n plus 1.
Nice. Where are your glasses?
Oh, yeah.
So, if this power is 6, look, there's 1, 2, 3, 4, 5, 6, 7 terms. So our number of terms is always 1 more than the power. What happens to the powers of the x's?
Goes n, then 10 minus 1.
Okay, so it starts at n and decreases by 1. Each time down to 0. Well, why have I said it's gone down to 0?
Because it doesn't exist.
Yeah, because we could secretly write x to the power 0 here, couldn't we? Yes, but we know that's just 1. And what happens to the powers of y?
Increasing by 1.
And what does it start at?
0.
Oh, that's not how you spell start. So it starts at 0 and increases by 1 each time up to n. Now the last one is a little bit more challenging. So we're looking at the coefficients of each term. So if I were to focus on this one, I can see this is a 1. It's a secret 1. And this would be a secret 1. This would be a 1. This would be a 1. Okay, so we're looking at 1, 4, 6, 4, 1. 1, 5, 10, 10, 5, 1. 1, 6, 15, 20, 15, 6, 1. Does anyone recognize that pattern?
Anything up and then down.
Okay, so no one recognizes it. It follows something we called Pascal's triangle.